It's time to start now, and I hope everybody can hear me. Good morning, everyone. My name is Maher Agassi. I'm with the Pure Aqua. We're going to be talking today about the containerized water treatment systems. So, the first thing that we're going to talk about what is containerized or mobile water treatment systems? Why is there a need for containerized water treatment systems? How do you choose the right containerized water treatment system? Then we're going to go through the project timeline. Then we're going to discuss a little bit some special features about the Pure Aqua containerization systems. Why Pure Aqua in general? And I'm sure we're going to have a lot of questions and answers. And we're going to maybe diversify a little bit here and there with every point that we or with every subject that we're going to be talking about. And please feel free to stop me for any question. You can send me the questions by by email or you can send it via chat to the chat window. Regarding the project timeline, this is one of the most important points we're going to discuss. The saving that the containerization that gives to the customer saves a lot of time instead of the construction and instead of the work. Now, the first question is what is containerized or mobile water treatment systems? As we can see here, any water treatment system that is insulated that is installed inside an ISO seaworthy or non-seaworthy container is considered to be, of course, any containerized or mobile water treatment system. Those options, like that comes inside the containers, to be able to ship it overseas, it has to be a seaworthy. Then after we make any holes inside the container, we still have to make sure that we plug all the holes and get like a seaworthy certificate to be able to export it overseas. Usually the available standard containers are either 20 or 40 or 45 or 48 containers. Well, we can customize some of the 10s and we can make high cubes. Now, as we can see, like more or less any water treatment system can be containerized. We can fit it inside a container. If it's not a single container, we can do it in a multiple containers, like 2 of the 40, 3 of the 40, 4 of the 40. We've done many jobs that accommodate 45 or 48 foot high cube. High cube means it's about 1 foot higher than the standard container. It's important that we get a seaworthy certificate, before we export the containers. Alrighty, now, why is there a need for containerized water treatment systems? What's the reason? So it's a very legitimate question and it's really important. So to understand the nature of the need for a containerized water treatment system. As we see here now, the first reason is a plug and play. So you get the system ready. All that you have to do, just connect in and out, drain, power, and just load the media. If there is a media, load the membrane, and just you make backwash for the filters, and it's ready to go. It's a mobile. It's a the system is mobile. It requires a very small footprint. The container. All what you have to do is just have the concrete pad for it where it's gonna lay down. Limited civil work, as we said. The only thing that you need is a concrete pad. It requires very quick installation. So few inlet and outlets, power, and the concrete pad. Turnkey delivery, that means the customer or the end user doesn't have to do a lot of work. Very limited. It is really, really ideal for remote sites where you don't have infrastructure. It reduces big time the permitting time. Like usually if you want to do construction, you're going to build a building, you want to get a permit for the power, you want to get a permit for the gas, you want to get a permit for the water, get a permit for the construction itself. So that saves a lot of time for the permitting. So instead of getting a permit for the entire construction, you only need a permit for the concrete pad, more or less. Now, one other feature that it's very easy installation, very easy installation. So inlet, outlet, drain, power. Then you put the treated water tank next to the container and just connect the level switch to the control panel. So it's fully automatic system. That's all that you need. Now, those containers, they works in hot and cold climates or environment. Like example, like if it's going to Saudi Arabia, you need the air conditioning. If it's going to Alaska, you need the heating system. One of the cool features that any water treatment system or wastewater treatment system, they can be customized and we can fit those inside containers. So we can accommodate like more than one container to finish the project in a proper good design where it's the areas that they require air conditioned, they are air conditioned. The areas that they do not need air conditions, they can be also non-air conditioned. First thing we look at the water analysis, then after that we choose the water treatment system. Then we see how many containers this water treatment system would require. Again, if you have any question, please text it to me via the chat room, or you can email and we will respond to the questions at the end of the session where there is a question and answer session. The next session is how do you choose the right containerized water treatment system. So there is like plenty of those. We have UF, we have MF, we have RO, we have media filter, we have MBR. So how do you choose those things? So this is a quick video that's going to show us how to do that. When I say quick video, it's a lot of renderings, a lot of illustration. So that's going to help us on how to do something like this. There are like major 4 different categories in like selecting container, like whether it's a water or wastewater treatment. Could be RO, brackish water RO, seawater RO. Could be ultrafiltration systems, or it could be media filters, or any other water treatment system. Now we know that like the fresh water available like in the globe is very limited, like so few percentage, and the rest is like non-safe seawater. So people they're increasing the population, and we need more fresh water. As we see here, there are 4 different categories to provide water treatment systems. The first one is seawater. The second one is brackish water. The third one is ultrafiltration, and the fourth one is multimedia filtration system. So it depends on the need. It depends on the need of the water treatment system that you're looking for. Again, we get the water analysis and we analyze the application and the process. Then we decide like what type of system we need to offer, and then we decide how many containers this design would require. It could be 1, it could be 2, it could be 3. Depends. Sometimes we could mix between 40-foot containers and 20-foot containers. It depends on like how much containers are required. I hope everybody can hear us, and again, the questions, please email them to me or send them to the chat room, please. One of the cool things about the containerized is it really looks nice and like safe because you can lock it, you can, protection for like vandalism from the environment. It's so simple, very easy, very neat. The flooring is diamond flooring, so it really looks very impressive. So those four categories that we see here, seawater, brackish water, ultrafiltration, media filter, they are not the only categories. We can do further than those. Those are some of the industries that they cover, like agriculture, like pharmaceutical. You can also do a lot of other different industries, drinking water, mining. You can do like USP water. You can do like wastewater treatment. You can do a lot of really different industries that can be utilized, such as plating, pharmaceutical, boiler feed water, cooling towers, mining industries, as we mentioned before, cargo ships. So a lot of rinse water. So a lot of different industries, as we can see here on the screen, that we can utilize to provide safe water to those industries. Ice making, you name it, all drinking water. This is a quick render of the container before we install the water treatment system inside. So we make the container ready. So we do the cutting, we do the opening, we do the flooring, we do the insulation, we do the wiring, electrical, air condition. As we see here, like the container itself is seaworthy. The conduits, the wiring that we prepare all those before we put the system. So we make sure it's easy after we put the system. After we put the system, it's going to be a little bit crowded. So um, now, as we see here, we also see the plate where we have the inlets and the outlets. You see all the main control panel, air condition. We modify the container, like we put flooring, diamond flooring. You see the LED lights on the top. So it's a lot of different things that we have to modify in the container. Sometimes we order double door opening, as we see on the left and on the right. We make like like a main entry for the operator, like a door. One good thing about the LED lights, it doesn't generate heat, so it keeps less heat inside the container. Also saves power, lives 20-25 years without any problem. So those are really good quality lights. The insulation saves a lot of power also. Other options that we are seeing here, the central external connections, they're all centralized. So all the connections will be in one area. The door, as we can see here, the walk-through door, they're like standard doors, 36-inch. Now let's take a quick glance on the insulation. That's how it looks like. The insulation, like very thick styrofoam. It gives about 2 inches thickness. It gives really good insulation. And we looked at the flooring. It's a diamond flooring. Now we're taking like a quick tour inside the container. That's a seawater project that we've done in Venezuela. So we look at the insulation and the covers after the insulation. Secondary cargo door, where like it makes certain flexibility to the customer. We mounted all the pre-treatment and plumbing all included, just plug and play system. The benefit of having a secondary cargo door, like sometimes you need to make maintenance from both sides, it's easier for the customer future maintenance. We also do like in anytime there is like media filter, we do an access hatch on the top, which is really easier for the future maintenance operators. They can upload the media from the top of the container. One cool thing about like this, so we also include all the electrical outlets for customers to connect, like if they want to install for like cleaning purposes, some vacuum cleaner or some pressure washer, or like for some small desk for the lighting, or they want to have any maintenance drill or whatever, you name it. So we install some electrical outlets for them. Now we again, like as a reminder, if you have any question, please send it to the chat session, where we can answer all the questions at the end of the session. I'm just taking it a little bit easy, so if somebody want to take some notes, so I'm taking my time. So now we will move to the like the next feature inside those containerized water treatment system. We will just talk a little bit about any water treatment system can be containerized, uh, like what we mentioned before, whether it's seawater, whether it's a brackish water, whether any UF or media filter. This is an example of like which is the seawater, how it works. So we look at those features: inlet shut-off valve, 5 micron cartridge filters, VFD, PLC. So it's all customized to handle the harsh environment of the seawater. As an example, duplex stainless steel 2205. It's amazing quality that resists the harshness of the seawater. We see the 5 micron cartridge filter is not non-metallic, so it handles also the corrosion resistance of the seawater. It also, you know, has the PVC, which is also all the piping for the low pressure side, and the inlet shuttle valve are all PVC material to resist the harshness of the seawater. Now, one cool thing about the system here, looking at the PLC control panel that has an HMI screen, you can watch the entire operation of the system on that HMI screen. The benefit of the inlet shut-off valve is it isolates the RO system when the RO is off, so you don't want the water to keep coming inside. One cool thing about our systems, like on every pressure vessel, we have a sample valve to make sure that the quality is good, and if there is any problem, you would diagnose where is the bad pressure vessel or the bad membrane. Now, this system also have all the instruments. We'll talk about it in a while. So very good quality components, and any metallic components that's touching the water it's higher than 316. It's always 2205 or higher. That will make the seawater like live at least 2-3 times the expected life span. Now, one also other things, the variable frequency drive, as we looked at it before, it's good because it gives like a soft start and stop. The difference between the summer and the winter in temperature that also requires some modification in pressure between the summer and the winter season. In summer, the membranes they will get a little the membranes require less pressure. So again, the variable frequency drive is an important asset for that system to control the pressure of the high pressure pump. And, it controls in the winter you need less pressure. In the summer, sorry, in the winter you need more pressure. In the summer you need less pressure. The reason because the membranes are polymers, and this is the nature of the polymers. It doesn't mean in the summer you'll get better quality, no, but I mean you need less pressure because the water passes easier. So it saves energy because of the variable frequency drive. It makes a high pressure pump survive more. You save pressure you control the pressure between summer and winter. So those are the main benefits of having a variable frequency drive, or what we call it as a VFD. Now, other things which is good having the VFD, like when the membranes get older, like 1 year, 2 years, 3 years, they would require a little bit more pressure, so it might boost up the pressure a little bit. Now, those are the fiberglass pressure vessels that can handle like 1000 or 1200 psi. Depends on the design, it depends on the feed water TDS. Those like designed for seawater. As we mentioned before, the high pressure piping is designed based on 2205 duplex stainless steel, schedule 40. They're very thick material, and they're designed to handle the harsh environment of the seawater, temperature, TDS, and high oxygen inside the seawater always. Again, those are like duplex stainless steel, very high quality. That's the cool thing about it. We've seen seawater systems, they start corroding if you are not using duplex stainless steel. They start corroding or leaking water after like few months. So it's really a must to use duplex alloy or duplex stainless steel alloy in the seawater. Frames that we usually use in the seawater, they're like very thick material, 6 inch or even like sometimes more, C-channel, and they're all powder coated. This is a cool feature, which is an energy recovery device. Again, it's made out of the duplex. We take the water that's coming out of the drain and we pass it to the energy recovery, and that boosts up the pressure that's coming out of the high pressure pump. So that would save about 35 to 40% pressure, which is a lot of energy. The seawater reverse osmosis systems, they consume really good amount of energy because the TDS is really high. The higher the TDS, the higher amount of energy that you would need for the seawater or for any reverse osmosis system. Now, pressure gauges that we are using, they all come with the diaphragm sealers. That means the diaphragm sealers is acting as a seal between the seawater and the instrument itself. So the seawater is not touching the instrument itself. The glycerin is the one that's touching the instrument itself. Now, looking at the high pressure pump now, it's a multi-stage type. It's a duplex stainless steel 2205, and it's a high quality. It's made in USA. So and they have like high efficiency. We've been using those pumps for a long time, and they're really very good quality components. So the pump is always undersized because we can compensate the pressure, the extra needed pressure from the energy recovery. So let's assume we need like 800 psi. So we get 450 to 500 from the pump, and the rest we can get it from the energy recovery. Looking at the digital instruments, whether it's low and high pressure switches or duplex, conductivity sensor, paddle wheel flow meter, mag meter, ORP or pH electrodes, they're like most of those instruments are included to make the system fully operational and fully automatic. Now here the system is ready. Just slip it inside the container, and then after that we start working with the pre-treatment, which is like media filter, and that's gonna go on the right side here. That's the media filter and the chemical dosing and all those things. Now looking at that container, it has doors on the left and doors on the right, which makes it easy to replace the membranes in the future. This is like a typical example for something that we build. This is like about 64,000 or 70,000. No, that's about, sorry, this is about 100,000 gallons per day, including the media filter, including the flushing, including the cleaning. That's a case study that we're going to talk a little bit quickly. This is a project that we've done last year, and it included 13 systems. Each system is 100,000 gallons per day. The containers went to Venezuela. Application was for drinking water, and you know, water source was open intake system. So the customer did a little bit of screening, and they store it in a tank, and then chlorination, and then the water was fed to our containers. The system included all the pre and post treatment components to make the system fully operational and fully automatic. The feed water TDS was about 36 to 37,000 ppm. System included the air conditioning, including the LED lights, including the insulation, including the diamond flooring, including the insulation, and included a lot of different features. So as we see here in the picture, everything was strapped nicely neat, and you know, now the system has been working maybe more than 14 months right now. So all the containers. Again, this is seawater. Feed water is about 36 to 37,000, and the quality of the water was according to the WHO regulations, which is good for drinking. Again, like when you are looking at seawater, everything else has to be non-metallic or high quality alloy like Duplex 2205. Now we covered now the seawater. Now we're going to talk about the brackish water. Brackish water desalination is very similar to the seawater, but I mean like here we can be a little bit flexible with the material since the TDS is not aggressive like the seawater. Looking here, the feed water is going to go from the left side here to the feed pump. Then it's going to go to the 5 micron filter. Then from the 5 micron filter, 5 micron filter is 316L stainless steel. It's going to go to the high pressure pump, multi-stage high pressure pump. That's also 316L stainless. That's going to go to the membranes. The inlet valve is usually a butterfly valve in those big systems, and they're good quality. Looking at the pressure vessels, they're fiberglass. High pressure piping, it's also 316L stainless steel. All our industrial RO systems, they have sample valves. We use C channel for the frame. The pressure gauges, they're like 316L stainless steel. The feed pump is optional because sometimes like water comes pressurized, so not everybody wants a feed pump. Instruments, the same thing here. We have the digital instruments included to make the system operational and make systems work without any problem. Now we're gonna have the system side, the container again. That's ready outside. We just slip it inside, support it, mount it, and then we bring the media filter. That's a render of a system that we've done. It has a 84-inch diameter feed and backwash pump, chemical dosings, and included the reverse osmosis system itself. This system, was giving about 380,000 gallons per day. Looking at the hatch doors here, like those are good for maintenance from the top. That's a case study that we just were talking about. 380,000 gallons per day brackish water RO. It went to Iraq. Application was TDS reduction for a cement manufacturing facility. That's a touch screen. How the touch screen are like nice, neat, and very informative. You can watch the entire system, like control it. That's a feed and backwash pump picture. And this project was designed for a high TDS, reached up about 8,000 ppm, which is called high brackish water. And now, like what we mentioned, all the components were included to make sure that the system function fully operational and automatic. That's how the container looks like. So looking at the AC, it wasn't included because we just shipped it inside the container. Now, the next system we're going to talk about is a UF ultrafiltration system. Ultrafiltration system. It includes all the components, including UF modules, PLC, screen, instruments. So whatever systems, whatever components required for the system to make the system fully operational and fully automatic. Now, one cool thing about the components we use in the butterfly, again, everything we use here is non-metallic, so everything is plastic because you don't need high pressure when you operate the UF system. UF, cool things about the UF, very good system to reduce BOD, COD up to a certain limit, and it's really excellent to reduce the BOD and viruses and bacteria and traces of and high amount of suspended solids. So it's really the best for suspended solid reduction, viruses and bacteria. Those are the digital instruments we talked about. So we include whatever required instruments to make the system, run without any problem. One thing that we recommend here for the UF is a turbidity meter, just to make sure that the system is rejecting high suspended solids and turbidity. The turbidity usually comes in NTU, nephelometric turbidity unit. That's what it measures. Now, UF can handle high amount of suspended solids, and it's really an excellent pre-treatment for the reverse osmosis. That makes the reverse osmosis work like really on high flux. So it gives more water. Like the RO can start producing more water if you use the pre-treatment, the UF as a pre-treatment. So looking at it here, putting the UF inside. So the other portion of the container can include all the chemical dosing, like for the chemical enhanced backwash, the tanks, the cleaning systems. So whatever systems that you need, it can be included in the container. Also, many shipments that we did, or many containerized system we did, where it combines both UF and RO, or UF and other filters. So it depends on the application itself. So most of the containerization is optional. As an example, this one is like includes the triplex system, including the flushing and the cleaning tank. It includes all the chemical dosing system. That's the case study we're going to talk about that went to Colombia, to the country of Colombia. It's about 54 gallons per minute. And the purpose of this project was to treat the landfill leachate wastewater. The leachate is the juice or the concentrate that comes out of the trash bins and any wastewater concentrated that comes out of the lands because of the soil conditioners and because of the soil. So this is all nasty for the environment. So now the new regulations forces everybody to treat the wastewater that is coming out of the leachate. The bad thing about the leachate also, it's not only high in BOD and COD and suspended solids, it is also high in TDS. So most of the time you need to use both, a combination of um, ultrafiltration systems and followed by a reverse osmosis system. Since we know that the UF is the one who is handling the suspended solids and the RO is handling the TDS reduction. Looking at the container side, so look how neat it's the design, and like everything is strapped properly, and the flooring is diamond flooring. So that particular system included the UF filters and the RO. So and the cleaning system. So again, take notes please for the questions, and send your question to the chat room so we can answer those questions. The next session will be talking a little bit about the media filtration. You know, media filters could be different tanks, could be fiberglass, could be stainless steel, could be epoxy coated carbon steel. Depends. Like in seawater, we use fiberglass filters because they're good for seawater. They don't cause any corrosion. Some industries like pharmaceutical and beverage, they always prefer stainless steel tanks. Some people they also prefer epoxy coated steel tanks because it's robust, it's very heavy duty. So it depends. So everything comes included the face piping, and they come mounted inside the containers and supported. So we could also have all the piping, the face piping with those filters on a pipe rack. So we install the tanks and we just slip the pipe rack inside the container, and then we can mount it and we can like support it with the piping. Taking a look at the internal distribution system, it's non-metallic, very unique slot design, make the flow harmonized and steady. PVC face piping, Schedule 80 according to the ASTM standards. As we mentioned a little bit earlier about the mounting options, it could be on a skid or it could be on a pipe rack. Makes it easy for the customer and simple. Taking a look also at the filters, we have pressure gauges and we have the vacuum breaker. In cases like fiberglass tanks like those, we always recommend to have a vacuum breaker because those filters are designed to handle high pressure but not vacuum pressure. So they can handle 100, 120, 130, 140 psi, no problem. But the vacuum pressure, negative pressure, is no good for the fiberglass. It's okay for the stainless and epoxy coated steel, but not the fiberglass. So always, anytime you have a fiberglass tanks, you must install like a vacuum breaker. Looking at the instrumentations that we offer in media filters, pressure gauges, paddle wheel flow meters, differential pressure switches. Differential pressure is a cool device that triggers the difference in pressure between the inlet and the outlet and gives the signal to the main control panel to the main control panel to start or initiate the backwash. The backwash can be initiated with using differential pressure switch or a DP switch, or through a manual initiation, or through a time intervals, or on a specific time. So you can do it like, let's say 24 hours between the intervals, or you can do it at 2 a.m. exact time, or you can do it using a DP, or you can do it with a manual initiation. Looking at the media filter when you slip it inside the containers, other things can be included: feed and backwash pumps, tanks. Like this is a rendering for a project that we've done in Alaska, where it's really very cold in that weather, in that state, where the temperature is always cold, especially in the winter. So the customer requested like epoxy coated steel tanks and included the carbon media, where the purpose, was, they want to reduce some organic. Now looking at the valves, all those valves, like fully controlled by a PLC. Container included the air conditions, but the air condition wasn't for the sake of cooling, it was for the sake of heating. And we included a standby heater just in case something happens to the first one as a standby. So this is the one I talked about. It's a filtration system that went to Alaska. It's a 520 gallons per minute, and the application was for a gold mine in Alaska. And the purpose of this one was to eliminate the organic matter, so organic reduction. System included like top of the line heating system to make sure that the climate inside the container is always controlled in a way where if it stops or if something goes bad, all the PVC inside the container is going to crack. You will take a look at the picture right now where it shows like the heating system, like the secondary one, like all the way inside. That's a picture of the internals. The internals are also non-metallic. We always like to use PVC non-metallic sometimes, unless like if the job is going for a beverage or pharmaceutical, we use stainless steel internals. This is like a little picture of the diamond flooring. If you look at it, make it safe for like corrosion, and it's good for like it's anti-slippery system. That's also the terminal panel where all the connections all centralized. That's the main heating system in the back. We look at it besides the secondary one. So we have this main heating one, and then we have another one inside just in case if this one fails to work. Again, we have two heating systems in that container because we don't want to take the risk and one of them goes bad. So if something goes bad inside the winter, like in December or October, November, December, January, February, it's going to be a problem. Taking a look at the outside picture of the container, this picture was taken like maybe 1 or 2 years after the system was operational. Take a look at the pipes outside that are coming to the container. They're all insulated because the water is really freezing. The ambient temperature is really freezing. So maybe you can take a look at the concrete pad that they've done, and that's the only work: connections, power, and the concrete pad. Now, why Pure Aqua Containerized Solutions? We already talked about this, but that's a quick summary: plug and play, mobile, small footprint, limited civil works, quick installation, turnkey delivery, ideal for remote sites or remote locations, reduce the permitting time, easy transportation, works in cold and hot environments, treat a wide range of applications. This is a list of again, the features. That's good. I'm listing this down again because honestly, this is one of the most important points inside this webinar, because it shows the benefit to the customer and to the end user. I hope everybody's taking notes so we can answer all the questions at the end, because we're going to be quick in answering questions. So we're like running a little bit out of time. Remember to ask any question about applications, containers, reduction of any components, what type of components we can, or what type of systems we can install in the containers. So you have a lot of questions that if you want to ask. So good thing about, I have one of the clients asking what is the amount of temperature that the UF can handle. About, like, I would say, like, about, we shouldn't be like more than 45 degrees Celsius to maximum 50. Um, it's polymer, so if you go higher than this, that's gonna make the polymer like pass and leak more like constituents and suspended solids. It doesn't mean it's not gonna work in the summer. No, it is, but the system should be designed to match like the temperature that the system is gonna operate in the summer or the winter. So we design it based on both conditions. Remember, like, UF gives like better rejection, way better than the size of virus or bacteria. So it's very safe to drink water out of after the UF, and after you treat it with the UF, and maybe a post treatment of UV sterilization. Now, BOD and COD, the UF is not designed to reduce high amount of BOD and CODs. If you want a system that reduces the BOD and the COD in a high manner, I would recommend that you go to the MBR, membranes bioreactor, and this is available on our website. Another question is, like, a customer from Kenya is asking, like there is a mixing between the waters that animals or livestock and people, they get the same water from the same location where it's polluted by livestock. Yeah, UF is a very good application for that, because most of the time, like in this case, there's a virus and bacterial contamination, and UF is a very good application for something like this. But I always recommend after the UF to install a UV sterilization, just to make sure there is no breakage in the fiber. One other question is, what's the smallest size we can fit in a container? What's the largest size we can fit in a container? I mean, we have as small as 1,000 gallon per day, all the way up to 1,000,000 gallon per day. So we can, like, have multiple containers. Like, if the system, one system cannot fit one container, we can divide that system into multiple containers. So to answer your question, we're flexible. Another question: which is better to reduce, like, if there is any combination of TDS and viruses and bacteria in the water? Well, you need both systems here. You need UF to reduce viruses and bacteria, and RO to reduce the TDS. Another good question: when do you use ultrafiltration with solar system? Well, UF doesn't require a lot of pressure, so it's a very good application for utilizing the solar panels with the UF system. However, if the TDS is low, you still can use like tap water or brackish water RO with small RO systems using solar. But I mean, it's going to be really expensive to use seawater using solar power, because the seawater requires high pressure, and you end up using a lot of solar panels, where it's going to turn to be expensive. I mean, still, for most probably for seawater, I would use power generators if the city, like, is not offering a power connection to the site. Now we're gonna move to project timeline. When we say project timeline, we're gonna make a little bit of comparison between between the having like a water treatment system inside a container, or inside a building. So looking at it here, you have when we do the quote or the estimate to the customer, back and forth questions, and then we get an order, and then we're going to do the engineering, back and forth design approvals with the customer. Then manufacturing time is going to be around 6 to 8 weeks, depends on the size. Then we're going to ship it overseas or inside the US. So it's going to vary between all the way up to 4 weeks. It depends where it's going. If it's going to California, like one day, Mexico maybe a couple of days, Central America maybe a week, or it's going to go to central of the USA, maybe 2 3 days. It's going to New York maybe 4 days, 5 days. It's going to the Middle East about 4 weeks, 5 weeks max. If it's going to Malaysia, 3 weeks. So it depends where it's going. So we can't control the sailing itself because those are all depending on the how many shipping or carriers steam lines they're offering a week. Then after that we look at the construction where we're going to make a significant saving. Construction usually for containers, like when we send everything ready, is going to be so quick installation, concrete pouring. So the only thing that the customer needs to do is a concrete pad under the container or the footers. So you can do either concrete pad, the whole thing as a slab, or you can do like 6 or 8 concrete footer. Now, why Pure Aqua? Why Pure Aqua as a good supplier or manufacturer for your system? I mean, we've been doing systems since long time. We supplied a lot of thousands of systems, and they're operational. We were like an industry leader in a lot of different designs. We we have very good like strong pre-engineered or standardized systems, and we also have customized water treatment systems. One cool thing about Pure Aqua is like, let's assume that you have a component or like a water analysis that requires custom system. So we take the best standard that can get close to that among our standard system, and we start to customize this standard system so we can save money on the customer. We have an ISO 9001 quality management system. We have excellent global experience worldwide. We have very quick response, like to customer support and quotations, leads, and all those things. We speak at least 5 6 languages in the company, and we have exceptional customer service and engineering support. And we have very good global experience that we couple it with our local agents, like so we can make it strong and cheap on the end user. So our agents, they most likely they come to our facilities for training, and they get trained. So where they make the installation smooth and easy, and they hand it over in their own like country. Now, Pure Aqua, you know, we specialize in reverse osmosis as a core of our business, and UF. And anything that requires as a pre-treatment before the RO or after the RO, such as media filtration, water softeners, chemical dosing, electrodeionization. We are excellent in it because we've done thousands of those projects. We've done projects in any country of the world. So whatever you name any country, we have good reference in it. So the reason we are mentioning that because we have experience the difference electricity, like whether it's a 50 hertz, 60 hertz, the voltages like in Japan is different, in Canada is different, in the US is different, in Saudi Arabia is different. So we come we reach to the question session where we already answered a few questions, but we're gonna take more questions now if there is anybody still has some questions. Now somebody would tell me what's the main difference between the membranes of the seawater and the brackish water. Well, brackish water membranes are looser, they have lower rejection, they require less pressure. Seawater membranes, they have high rejection, they need more pressure. Somebody would ask me where can I find the containerized systems, like different capacities in the water treatment systems and in containerized, where can I find them in the website? You need to go to the customized system, and you see all the 3 different or 4 different types we are offering. Any water treatment system can be customized inside a container. So you will not be able to find a specific capacity for containerized. You choose the system that you want, and then tell me that you want it in containerization, then we can add those two and send you the quotations. So first, see your system that you need, and then just send us to one of our customer service that you are looking for containerized system, and we'll communicate with you accordingly. And by the way, after this session, we will record this webinar and produce it in a YouTube format, and we're going to post it in the YouTube so anybody can watch this video. We will send an email to all the attendees informing them with the link so they can watch it again. Some of our participants, they had a little issue with the voice, the audio. It could be the non-compatibility of the browser. So some people that are using Windows Explorer, some people that are using, so we do apologize for like some of the clients, they were not able to hear the audio. And I do thank so much the customer, they participated and they had a lot of good questions, and we really appreciate your time. And the next webinar is going to be about the brackish water reverse osmosis systems, and we will end up this session, and we thank everybody again. Thank you so much.